Okay, section 3, example 5. Express 2x squared plus 4x minus 3 in the form a bracket x plus b all squared plus c. That's a complete square question. So I've got 2x squared plus 4x minus 3. The best way to think about these complete square questions when it's not a unitary x squared, as in 2x squared or 3x squared at the start, 4x squared for that matter, is look at the first two terms, almost kind of think about minus 3 as an afterthought that you're going to write down at the end. Now the best way to go with these is with the first two terms. First of all, we'll take out a numerical common factor, so that would be 2. So it's 2 bracket x squared plus 2x, close the bracket, minus 3, so I've not really did too much there. Just taking out a numerical common factor from the first two terms. Then do the completion of the square, and that's x plus 1 all squared, halving the 2 down to 1. I've got 2 in front. Now what comes out of there is 1 squared, which is 1, but you need to multiply that by 2, so it's actually 2 that comes out, so you need to get rid of 2, and then you're still getting rid of 3 as well. So that's going to be 2 bracket x plus 1 all squared minus 5. To get the turning point, you change the sign of 1 to minus 1, you don't change the sign there, minus 1 minus 5, and that is your turning point. Okay, section 3, question 6. Rather than this being a kind of examination type question, it's more an explanation of the relationship between exponential and logarithmic functions and graphs. So what I'm going to do here is sketch the inverse function to y equals 4 to the power x. Now the inverse function to y equals 4 to the power x is log to the base 4 of x, and that's the relationship that 4 to the power x has got with log to the base 4 of x, that they're inverse functions. 10 to the power x log to the base 10x, a to the power x log to the base a of x. Now remember that inverse functions have a line of symmetry, which is y equals x. So y equals x is a line with gradient 1 and a y-intercept of 0. So first of all, if I was to think about sketching 4 to the power x, well, if x was 0, y would be equal to 4 to the power 0, and the power 0 is equal to 1. If x was 1, then y would be equal to 4 to the power 1, that's 4. If x is equal to 2, y would be equal to 4 to the power 2, and that's 16. So that curve would look a bit like that. Now the associated logarithmic function then would be called log to the base 4 of x, and that would go through, instead of 0, 1, 1, 0, instead of 1, 4, 4, 1, and instead of 2, 16, 16, 2. And you can see that there's been a flip of the x and the y coordinates. Important thing that you want to take out of this short example is that y equals 8 to the power x always goes through 0, 1, and log to the base of x goes through 1, 0. And y to the power, y equals 4 to the power x, 0, 1, 1, 4, log to the base 4 of x, 1, 0, 4, 1. So in general terms, y equals 8 to the power x, 0, 1, 1a, and for log to the base a of x, 1, 0, a1.